Now, it also says that after his feet touch, he moves an additional 0.6 meters. That's about another 2 feet downwards. And why does that happen? That happens because his legs collapse down. And so his feet touch when his feet first touch, basically his tippy toes are touching, his legs are straight, and then when he actually hits the ground, his knees buckle, his legs accordion style compress, and hopefully he doesn't fall down, but basically the center of his mass drops another 0. In our case it's 0.6 meters, but you know, whatever. I'm going to just call this H. I'll call this fancy H. There's a little height that he squishes down. It's about 0.6 meters, which is about 2 feet. So he basically becomes 2 feet shorter in the time his feet first touch the ground to the time at which he stops. Remember, he's not stopping here. We calculated a velocity that he just touches the ground at, and then he comes to a stop. So now his final velocity there, we called this initial velocity, we called this final velocity, so now we're going to call this final velocity is equal to 0. So he stops at that point. And he did that over a distance of 0.6 meters, or some little h. You guys are going to have different values there. What's the magnitude of his acceleration now? Well, this final velocity, we're going to use the same equation, but it's going to be his final velocity is equal to his initial velocity, which given here is equal to his final velocity in the first part. So the end of the first step becomes the beginning of the second step. So as long as you can take care of this, well, anyway, this is a movement in distance, and now we have a new acceleration. There's a change in height. This change in height is from, well, we know the change in height is 0.6 meters downward. So I'm going, it's 0. Well, it's negative that little h, whatever your little h is. So our final velocity is 0. This is part B. Our final velocity squared here is, well, actually we could actually, we know its answer here, but we also could just say it's equal to 2gh. But anyway, it's this answer. We know what this is. It's the square of the value we figured out here. And we know this is a, and we know this is negative h. So I'm going to put that little change in height, about 0.6 meters. All right, so the question is, what's the magnitude of the acceleration? So to find out, I'm going to add 2a h's to both sides. So this added to this is 0. 2a h's appear on this side. And if I, to isolate for this a, I need to bring over, I need to divide by 2 and 2 and that h. All right, now I can find the acceleration. Because this h, oh yes, notice this is a positive value. I had a negative h here, but it went over to the other side. And so this is going to be a magnitude, but it also, we've been keeping track of our signs. This means it's upwards. And that's the answer to part C at the same time, because this is an acceleration upwards because this is positive. So he hits the ground, he's moving downwards and he stops. So his acceleration must have been against his movement. He was coming downwards with a downwards velocity. He comes to a stop, and in order for a downwards velocity to come to a stop, there would have had to have been a change in velocity upwards, and that's an acceleration upwards. So we now know C, we know B, D. I think I'll wait for another video.